Joining us now for more, Harvard professor and astrophysicist Dr. Avi Loeb. Great to have you back tonight. So 2 weeks, Dr. Loeb, after taking pictures of this thing, NASA is still refusing to make those photos public. They're blaming it on the shutdown. What is NASA hiding? Are they hiding something?
Thanks for having me. Well, I'm still of the belief that if they are slow, it's not because of extraterrestrial intelligence, but because of terrestrial stupidity. And so we should just wait, in my opinion. Indeed, the NASA image from the high-rise camera on top of the Mars Reconnaissance Orbiter should give us a pixel resolution of 30 kilometers, 3 times better than the previous best image from the Hubble telescope. So we should just wait for that. And the object would actually reach closest approach to the sun in just a week on October 29th.
Right.
That's around the time of Halloween. And we shall see if it wears any customs, if it changes the direction, maneuvers. That would be the optimal time to do so. We can't observe it from Earth because it's hiding behind the sun, perhaps for a purpose. It could also release some mini probes that would approach the planets. And I asked my Galileo research team to look for any unusual activity in the coming months.
Okay, let me stop you just because now I've got multiple questions. I'm sorry to cut you off, but okay. So have you reached out to NASA? Because this is just, look, I operate in the real world, and NASA's supposed to release photos within 24 hours. It's been 15 days. They're blaming it on the shutdown. You're buying that? If there's nothing to hide, then have Jerry at NASA release the photos. It's that simple, right?
Yes, it's actually not NASA. The principal investigator of this camera is at the University of Arizona, and I actually sent an email asking him for the data. He didn't reply. So
wow.
I'm not sure exactly what is going on, but I'm not willing to speculate, and I will use as much data as we have. Of course, I'm very much eager to see it. The other advantage of that image is that we will look at the glow that is presumably started in front of the object, now turning to be behind it. We will see it sideways for the first time when it passed close to Mars.
Dr. Loeb, there are images online circulating right now that seem to show not a giant rock like a comet, but what looks like a fleet of spacecraft sort of clumped together. Have you seen these images?
No, I haven't, and I don't know how reliable they are. There is a lot of misinformation, so we have to be careful.
Okay, next Wednesday you mentioned October 29th. So 3i Atlas, essentially it's behind the sun right now. It will reemerge next Wednesday, and if it is a comet, it should essentially stay on course and head out into outer space. But if it does veer to the right and head toward Earth, that means it is intelligent, and then what happens next?
That's an excellent question. I think Washington, D.C. will have to attend to it. But of course, it doesn't need to change course itself because it's a very massive object, at least 33 billion tons in mass. So it could, for example, release mini probes if it's a mothership.
Okay.
So we have to watch for both possibilities.
When do we know for sure if this is a mothership?
We will know when we see the children of the mothership visiting us, coming closer to Earth. Of course, objects that are of the size of our spacecraft, of order 10 meters or a few tenths of meters, they would be difficult to observe because they don't reflect much sunlight until they come close to the atmosphere of the Earth, and then we will see them. It might be too late.
Are you saying that this, on Wednesday, could reemerge on the other side of the sun and release smaller probes like the movie Independence Day that could then potentially make their way toward Earth? Is that what you're saying? And then I'll just add to that, are you concerned?
Well, it is a possibility. Now, what many scientists miss in this context is that it has implications for humanity. It's not like any other scientific study where you can say, I don't really care what the dark matter particle is. It will not affect my future life. But here there are implications, and therefore we have to be worried about black swan events because of their huge implications, even if the probability that you assign to that is very small. So I think we should look into as much data as possible. And there is a spacecraft called JUICE that is operated by the European Space Agency. They are much more transparent than NASA. And that should, in the first week of November, tell us more about this object.
But next Wednesday, we should at least have some answers if NASA is finally honest with the people of the world, not just the American people. The government shutdown should not impact NASA releasing photos if
What if an object from beyond our solar system is not what we think it is? What if it's not a comet at all, but something far more deliberate, far more intentional, far more extraordinary than conventional astronomy has prepared us to accept? Tonight, we embark on a profound journey into the mystery of 3I Atlas and the startling claims made by Harvard professor Avi Loeb, one of the most controversial yet intellectually rigorous voices in modern astrophysics. He asks the question that keeps scientists awake at night. Could this interstellar visitor actually be alien technology? And if so, why now? What does the evidence really show us? And what are we possibly ignoring in our rush to categorize this object as merely another cosmic wanderer? These questions demand our attention because they challenge the very foundations of how we understand our place in the universe. Discovered on July 1, 2025 by the Atlas Survey in Chile, 3I Atlas entered our solar system from interstellar space, marking the third known object of its kind to arrive from beyond our cosmic neighborhood. This distinction alone places it in rarefied company, joining Oumuamua and Borisov as one of the few confirmed interstellar visitors we've ever detected. Typical comets behave in predictable, well-understood ways that astronomers have catalogued for centuries. They carry ice and rock. They develop characteristic tails as solar radiation vaporizes their surfaces. They follow expected trajectories governed by gravitational laws we've refined through generations of observation. But 3I Atlas presents something fundamentally different. It presents a catalogue of anomalies that refuse to fit neatly into our established frameworks. For instance, its trajectory is remarkably close to the ecliptic plane of the planets, a geometric alignment that represents a rare coincidence if it arrived through random interstellar wandering. The probability of such precise alignment occurring by chance alone stretches the boundaries of statistical likelihood, and the chemical signatures detected through spectroscopic analysis. Some data suggest it may have a carbon dioxide-dominated coma with unusual ratios that diverge significantly from what we expect in conventional comets. The composition appears subtly but distinctly different from the standard model of interstellar debris we've developed through studying other objects. So we must ask ourselves the fundamental question: are we observing a natural visitor or something entirely different? Avi Loeb is no stranger to controversy, and this fact is crucial to understanding the context of his current claims about 3I Atlas. He sparked major scientific debate and considerable institutional resistance with his hypothesis that 1I Oumuamua might have been a probe sent by an alien civilization. This wasn't a fringe claim made in obscure publications. This was a serious scientific argument made by a tenured professor at one of the world's most prestigious universities, presented through peer-reviewed channels and defended rigorously against criticism. The scientific establishment largely rejected his Oumuamua hypothesis, but Loeb persisted in his methodology: follow the evidence, question assumptions, and refuse to dismiss possibilities simply because they sound like science fiction. Now he turns his considerable intellectual firepower toward 3I Atlas. In one of his recent essays, he states something that encapsulates his entire philosophical approach. As a scientist, I respond to evidence collected by instruments. As of now, we have anomalies, but we need more data. This statement is crucial because it reveals Loeb's methodology. He's not claiming definitive proof. He's identifying patterns in the data that warrant deeper investigation. He's challenging the implicit assumption that has dominated astronomy for decades, the assumption that we should default to natural explanations for all interstellar objects unless extraordinary evidence forces us to consider alternatives. He challenges what he calls the comet by default paradigm, the institutional bias toward assuming every interstellar object is a comet until proven otherwise. He suggests a thought experiment. If 3I Atlas were actually a technological artifact, how might it behave differently from a natural comet? And indeed, when we examine the observational data through this lens, some behaviors appear distinctly odd. The object exhibits a weaker than expected tail, jets that appear oriented sunward rather than away from the sun in the expected pattern, and unusual alignment characteristics that don't match our models. Loeb and his colleagues even proposed the idea of sending a 6-word message toward 3I Atlas, not because they're claiming with certainty that it's alien, but as a thought experiment exploring what we might do if it were. His tone throughout this discussion remains measured and scientific. Let's not dismiss the possibility Because it sounds like science fiction, let's examine it rigorously. This approach represents a fundamental challenge to how mainstream astronomy operates. It's an invitation to expand our investigative framework rather than contract it. But we must ask the hard questions, the uncomfortable questions that separate rigorous science from wishful thinking. How strong is the statistical case for an unnatural origin? Loeb points to the trajectory alignment, the unusual speed profile, the chemical makeup that diverges from expectations. Yet many astronomers argue that the data remain entirely consistent with a genuinely weird comet, an object formed under unusual circumstances in another star system and now passing through our neighborhood. Could the anomalies be explained by unusual formation circumstances in a distant stellar system, or by observational biases in how we collect and interpret data? What would actually count as definitive proof of artificial origin? Loeb suggests that resolved imagery showing artificial patterns, detecting artificial signals, or identifying structural features inconsistent with natural formation might transform speculation into genuine science. And there's the institutional risk to consider. Making a claim too early without sufficient evidence can undermine credibility and distract the scientific community from more plausible explanations. Some in the scientific establishment argue that leaps toward alien probe conclusions prematurely distract from more methodical natural explanations that might ultimately prove correct. So we must balance our curiosity with scientific rigor, our wonder with skepticism, our openness to possibilities with commitment to evidence. Now imagine for a moment that Loeb is right, that his analysis is correct, that 3I Atlas does indeed represent artificial technology sent from another civilization. What then? What are the implications? If 3I Atlas is genuinely a piece of alien technology, does it carry intent? Is it passive and observational, simply collecting data about our solar system and our civilization? Is it actively engaged in some mission we don't understand? Or could it potentially be hazardous in ways we haven't considered? Loeb has referenced the dark forest scenario, a concept from science fiction that explores why intelligent civilizations might choose to hide their presence. In this framework, visibility equals risk. A civilization that announces itself to the universe risks attracting hostile attention from entities more advanced or more aggressive. Perhaps what we're observing is a probe sent to gather intelligence while maintaining operational security. How would humanity respond to definitive proof that 3I Atlas is artificial? The detection of artificial origin would force a paradigm shift of unprecedented magnitude. We would no longer be merely observers of cosmic objects moving through our solar system. We would become participants in a cosmic drama, aware that we're being observed, that our solar system is within the operational range of another civilization's technology. This realization would transform our understanding of our place in the universe. What about risk management? If 3I Atlas is technology, what happens if it malfunctions? What if it collides with something? What if its purpose is something we don't understand and can't predict? These practical concerns demand serious consideration. Even if 3I Atlas ultimately proves to be natural, the discovery still expands our knowledge significantly and challenges our assumptions about how objects from other stars behave and what properties they can possess. What should we look for next? According to Loeb, high-resolution imaging from spacecraft, closer flybys if possible, and detailed compositional analyses using our most advanced instruments. He highlights the opportunity presented by the object's path near Mars orbiters and its potential approach to Jupiter in 2026. More data equals more clarity, and the trajectory of 3I Atlas through our solar system offers multiple opportunities for observation. For those watching and following this mystery, keep your eyes on upcoming telescope data releases, mission announcements, and peer-reviewed studies that emerge from the scientific community. Question everything you encounter. Are we looking at an interstellar visitor, or are we looking at an interstellar visitor with a specific mission? If you're fascinated by these questions, consider subscribing and setting notifications for updates, because we may genuinely be on the brink of one of the biggest discoveries in human history. The implications of confirming artificial origin would reshape civilization's self-understanding. Ultimately, the story of 3I Atlas and Avi Loeb forces us to confront the most profound question humanity has ever asked. Are we alone? Are we being visited? Or are we witnessing nature's surprises, the universe revealing aspects of itself that challenge our current models and expand our comprehension? The truth may lie encoded in the data, and we are just beginning to develop the tools and frameworks necessary to decode it properly. The scientific community finds itself at a crossroads with 3I Atlas, and this moment represents more than just another astronomical curiosity. It represents a fundamental question about how science operates, how we balance skepticism with openness, and how we respond when evidence presents us with possibilities that challenge our established paradigms. Avi Loeb's willingness to ask uncomfortable questions, to propose unconventional hypotheses, and to defend them rigorously against criticism represents a crucial function within the scientific enterprise. History demonstrates repeatedly that paradigm shifts often begin with individuals willing to challenge consensus, to propose alternatives that seem outlandish to their contemporaries, and to persist despite institutional resistance. Galileo faced the same dismissal. Einstein's theories seemed absurd to many established physicists. The detection of gravitational waves was considered impossible by mainstream physics for decades before finally being confirmed. Each of these breakthroughs required individuals willing to think differently, to follow evidence into uncomfortable territory, and to maintain intellectual integrity despite social and professional pressure. The question of 3I Atlas's origin forces us to examine our own cognitive biases and institutional assumptions. We default to natural explanations not because they're always correct, but because they're familiar, because they fit within our existing frameworks, because they don't require us to fundamentally revise our understanding of reality. This bias served science well when we were still discovering the basic rules governing our universe. But as we mature as a civilization, as our technology becomes sophisticated enough to detect objects from other star systems, we must ask whether this default assumption remains appropriate. Should we continue assuming natural origin until extraordinary evidence forces us to consider alternatives? Or should we adopt a more balanced approach, examining all possibilities with equal rigor, allowing evidence to guide us rather than allowing assumptions to filter evidence? This isn't a question about abandoning scientific standards. It's a question about applying scientific standards consistently and comprehensively. The evidence surrounding 3I Atlas, while not definitive, certainly warrants serious investigation. The trajectory alignment with the ecliptic plane is statistically unusual. The chemical composition diverges from expected patterns. The behavioral characteristics don't perfectly match our models of natural comets. These observations don't prove artificial origin, but they do justify deeper inquiry. They justify mobilizing our best instruments, our most sophisticated analytical techniques, and our most rigorous investigative methodologies. They justify the kind of serious scientific attention that Loeb is advocating for, and they justify resisting the impulse to dismiss the possibility simply because it sounds extraordinary, or because it challenges our comfortable assumptions about the universe. Consider the practical implications of different scenarios. If 3I Atlas proves to be natural, we gain valuable knowledge about how objects form in other star systems, about the diversity of interstellar debris, about the range of possibilities that nature can produce. This knowledge has genuine scientific value, regardless of whether the object is artificial. If 3I Atlas proves to be artificial, the implications transform everything. We would have definitive proof that we're not alone, that another civilization has developed technology capable of interstellar travel or communication, that our solar system lies within the operational range of extraterrestrial intelligence. This discovery would reshape philosophy, religion, politics, and our collective understanding of humanity's place in the cosmos. The stakes are extraordinarily high, which is precisely why we must investigate thoroughly and carefully. The role of life doubts and similar channels in this investigation cannot be overstated. Mainstream media often treats these topics with dismissal or sensationalism, failing to engage seriously with the scientific arguments. Academic institutions sometimes resist investigation due to fear of professional ridicule or loss of credibility. But independent channels dedicated to rigorous examination of these questions play a crucial role in keeping the investigation alive, in presenting evidence fairly, and in allowing audiences to engage with these ideas on their own terms. The democratization of scientific inquiry through platforms like Life Doubts represents a significant shift in how knowledge is produced and disseminated. It allows serious thinkers to reach audiences directly, bypassing institutional gatekeepers who might suppress or distort information. What makes Avi Loeb's approach particularly valuable is his insistence on maintaining scientific rigor while remaining open to unconventional possibilities. He doesn't claim certainty where certainty doesn't exist. He identifies anomalies and proposes hypotheses. He calls for more data and better observations. He acknowledges the limitations of current evidence while refusing to dismiss possibilities simply because they seem unlikely or extraordinary. This represents the gold standard of scientific thinking, the approach that has historically led to genuine breakthroughs and paradigm shifts. It's the approach that separates genuine scientific inquiry from both dogmatic materialism and credulous acceptance of every extraordinary claim. The coming months and years will be crucial for resolving the Three-Eye Atlas mystery. As the object continues its trajectory through our solar system, opportunities for observation will multiply. Mars orbiters will gather data. Space-based telescopes will capture high-resolution imagery. Ground-based observatories will conduct detailed spectroscopic analyses. Each observation adds another piece to the puzzle. Each data point either strengthens the case for natural origin or reveals additional anomalies that demand explanation. The scientific process, when allowed to function properly, will eventually produce clarity. The question is whether we have the intellectual courage to follow the evidence wherever it leads, regardless of how uncomfortable the destination might be. Consider what's at stake in how we respond to Three-Eye Atlas. If we dismiss it prematurely because it challenges our assumptions, we risk missing one of the most significant discoveries in human history. If we accept extraordinary claims without sufficient evidence, we undermine scientific credibility and open the door to pseudoscience and unfounded speculation. The challenge is to navigate between these extremes, to maintain rigorous standards, while remaining genuinely open to possibilities that challenge our current models. This is the essence of mature scientific thinking. This is what separates genuine inquiry from both closed-minded dogmatism and credulous acceptance of every extraordinary claim. The implications extend beyond astronomy into philosophy, theology, and our fundamental understanding of consciousness and intelligence in the universe. If we discover that we're not alone, that another civilization has achieved technological sophistication sufficient for interstellar travel or communication, we face profound questions about the nature of intelligence, the prevalence of consciousness in the universe, and the trajectory of technological development across different civilizations. Do all technological civilizations follow similar developmental paths? Do they inevitably develop similar technologies? Or is the diversity of approaches limited only by the laws of physics? These questions have occupied philosophers and scientists for centuries, and Three-Eye Atlas might finally provide empirical data to address them. The role of skepticism in this investigation deserves particular attention. Healthy skepticism is essential for good science. It protects us from accepting false claims, from being misled by incomplete data, from jumping to conclusions prematurely. But skepticism can also become pathological, can become a form of closed-mindedness that refuses to consider evidence that challenges established paradigms. The challenge is to maintain what might be called open skepticism, a stance that questions everything rigorously while remaining genuinely open to evidence that might overturn current assumptions. This is the approach that Avi Loeb advocates for, and it's the approach that the scientific community should embrace when investigating Three-Eye Atlas. As we contemplate the mysteries surrounding Three-Eye Atlas, we must also contemplate our own role in this investigation. We are not passive observers of cosmic events. We are participants in a collective human endeavor to understand our universe and our place within it. Our choices about what questions to ask, what evidence to take seriously, and what possibilities to investigate shape the trajectory of human knowledge. If we choose to dismiss Three-Eye Atlas as merely another comet without rigorous investigation, we make a choice about what kind of civilization we are. If we choose to investigate thoroughly, to follow evidence wherever it leads, and to remain open to possibilities that challenge our assumptions, we make a different choice. That choice reflects our commitment to truth, to understanding, and to the pursuit of knowledge, regardless of where it leads. The story of Three-Eye Atlas and Avi Loeb forces us to confront the most profound questions that humanity has ever asked. Are we alone in this vast universe? Are we being visited by intelligences from other worlds? Or are we witnessing nature's surprises, the universe revealing aspects of itself that challenge our current models and expand our comprehension of what's possible? The truth may lie encoded in the data streaming in from observatories around the world and in space. We are just beginning to develop the tools and frameworks necessary to decode it properly. The investigation continues, the data accumulates, and perhaps, in the coming months and years, we will finally begin to understand what 3I Atlas truly represents. Whether it proves to be a natural object with unusual properties or something far more extraordinary, the investigation itself represents humanity's commitment to understanding our universe. And that commitment, that willingness to ask difficult questions and follow evidence into unknown territory, represents the best of what science can offer. Keep looking up. The answer may be approaching from the depths of interstellar space,